Hello everyone, welcome to one more interesting session on machine learning. And today we are going to understand what is pre-processing, or we are going to get started with pre-processing for building a ML model. So machine learning is one of the most buzzwords of this century. Not only organization but people or resources are looking forward to learn what is machine learning because it's hugely in demand. Before we get started, let us have a quick round of introductions about myself. I am Krish and I am having an experience of 10 plus years in the ML field on machine learning and deep learning projects, and I work with different domains. So I have opened Python. Now let's move to the folder. First, program. So again, for importing the data into the Python environment, there are two different ways, but we are going to use the OS library for importing our data. We can use this program for doing a job. So but what we do first whenever you open this is restart and clear all inputs. So we are not using these. This is, we can just comment out because that is not required. So we will be using this. We won't be using this because that is not required. You can just again comment out and insert the column here. Okay, so just copy this code. Okay, prior to this I have to import my library. You can just delete as well, so you can just select and do the cut and it is deleted. So you'll need this library, create import OS. Now see, where is my data present? Okay, it's in Dell desktop data. So Dell desktop, and you have to just change the directory and type in data. Let's type the data. Okay, so let's see. Okay, let's give the data frame a name, and it is an XLS format, and I import it. Okay, your data is imported. Let's see how my data looks like. Let's take the header. So I'll press Alt and Enter. Oh, your data is imported. Let's find out the information. Okay, let's find out data.info just to find out what the format of my variables are or my datasets are. Okay, here you will have an idea how many variables are missing, or how many data you are, how many variables you are having, what variables are of which types, and how many null values are there. Okay, you see the total number of records you have is 196 entries, which is mentioned here, but you have like around 4 or 3 null values. So that's the reason we have to do some pre-processing. Let's look at the tail of this data so that if you can get an idea how the tail looks like, or we can find any blanks or hash NAs or anything. We know your data contains hash NAs, and also on top of that it contains a couple of blanks, so it is looking clean here, but in between there are a few records which are not clean. You have an idea like what the tail is looking to be. Now just have a quickly look at the data types present in your data. So for that I write data.d types, control enter. Okay, so the year is integer, month is integer, order ID is integer. You see, look at the issue here. Like FSN ID is okay, it's an object, that means it is a string. Order ID is order date, is date time, that's perfect. Year is integer, month is integer, order ID is integer. Order ID should have been string, because what happens, the issue here in Python is if based on whatever format the data types are, it's going to treat it in such a way. Like for example, if your order ID is an integer, it's going to do some manual calculations, like you cannot have any order ID in a decimal. Okay, so those things you have to take care. Like GMV is integer, that's perfectly fine. Delivery bad days object, delivery good days, so that those are object because those have some characters in them. So we are going to see to that. Contact number is float, name is object. Okay, everything is fine, but we have to we have to change the format of some of the data types, and only then we will be able to do a good analysis. Okay, when we are working with data, there are a couple of things we should remember. First job is data compilation and data collection, we can say, because the challenge arises which data to consider and which not to consider, and in that your some of the time or bandwidth is gone. Once you are fine like which data you're going to consider, and you have compiled the data, you have bought it using MySQL or Spark or MongoDB or any other data sources. Data source can be of any format, data can come in. Okay, once you're fine with the data set, the next step that you're going to do is all about pre-processing. Because pre-processing is one of the major steps for building a model. If I say building a model, it will be just say 30 or 40% of your efforts, but 60% of your efforts is done for the pre-processing. Because if your base or your data is not clear and your data format is not clear, your results that you're going to be is going to go berserk. Okay, like for example here, if order ID is not changed to an object, you are going to get a very bad results. Let's see how I changed the format of these data type. Now let us go ahead and change the data format. So for that we have to first select the column, and then we have to change that to the data type for which we are looking for. So how do we select a column name? So you first the data frame name. Data frame is based on the table that you have created, based on which you have imported the data. So you write the data, and then within box brackets under quotes you write the order ID. So this is the thing you need, the transformation. So again you write, select the same thing, and you type you're changing the data type and change it to an object, and press alt and enter. Now just double check on this data.d types. Okay, let's look at, okay, you have changed the order type, order ID, that's correct. Now let's move in and change the other data formats as well. So what you can do easily, for quick and easy, you can just copy that and paste it here, and just change the column name which you are looking for. Object, float, contact number. Yes, you have to change this as well, because contact number can never ever be a numerical. You can do never a numerical function on that. So customer ID is again float, so you have to change that. So these are some of the things which you have to remember, otherwise you are going to face a lot of issues. So this is again part of pre-processing. SLA factor, object, no issues, units, GMV, order, item ID. So this one again is creating an issue. We have to change the data types. Order ID, so now the issue will be year and month. Year and month, if you do not change it, you are going to see he is going to take it as treat it as a numeric value, and it's going to find out it's going to find out different do some calculations on the year, so which is not possible. You cannot have a fractional year. Yes, in years you can, because in 2020.5 you cannot have. Similarly for month, so you have to just change the format. Okay, you can keep it object so that nothing is taken care of, and you can do that and press alt and enter, or you can do a control enter and just check the data types now, and you'll see everything is correct. Okay, let's look at the integer, GMV, units, yes, SLA, yes, float, and these. So your data is correct now. Now for pre-processing, there is an important step which is known as investigation, or which is known as EDA, or Exploratory Data Analysis. What do we do in that? In exploratory data analysis, we find out what insights is present in the data. We find out what all trends is present in the data. We find out what all relationship there is in present in the data, and also we find out what is our target variable. Okay, so what is our target variable? So in house prices example I told you about, we wish to predict the price of the house. So but here, what is the thing that you are predicting, or what is the thing that's your concern is all about? You have product details, you have customer information, you have transaction details. So what is that thing that is driving it? You can see GMV. So this is the price of the product the customer has paid. So this is your target variable, based on which everything is dependent, because this is a customer data. So the GMV, the product price the customer has paid, so the number of transaction he is making, the number of the product categories he is buying, everything is dependent on these GMV. So that is what our target variable is. We have got let's talk about some of the dependent and independent variable. Dependent variable is that variable which is our target variable, or which we are forecasting, or which we are predicting. And independent variables are those variables which we are using to predict the dependent variable. That's it. Okay, for the I will show you one more library, so which is based on which we will be doing our EDA. This is one of the simplest library and will make your EDA very easier. It is known as Pandas Profiling. Okay, so let's see how to install Pandas Profiling. If you are new to if you do not have any idea of which library to install, now you know the library name, but you do not know which library it is related to. Like Pandas Profiling, if I type Pandas dash profiling, it won't work. So to be on the precise, just type it install Pandas Profiling, and Google is going to tell you how you're going to go ahead and install this library. Okay, dash profiling. Okay, let's open our command prompt. So just type in pip install Pandas Profiling, and your Pandas Profiling will be installed. It will take a few minutes to get downloaded, because with it comes a few of the supporting packages which also gets installed in your system. Okay, your library is installed. Now let's see, you have a little bit of description how to use it, and how to create the Docker, how to call this library, everything is mentioned here. Okay, so I'm going to call this library first. So I just paste it and press alt enter, and my library will be imported. The next thing what I'm going to do is create the profile report. Okay, so this is the data frame name, so that's so easy, and press Ctrl and enter. It will take some time to get this populated. So Pandas Profiling is one of the most interesting libraries, and it will save you a lot of time for the EDA part, and it is very informative in terms of, like, if you quickly want to find out the gist of the data, of what the data is talking about, how many blanks you have, how many outliers you are having, how's the distribution, what is the relationship between different variables. So all these sorts of answers will get solved using this library. So there are two ways where you can do. You can just ignore. You can just put in your pandas. You can just remove this part and run the code. It will work. Okay, but you have to make sure, like the error I got. You might face some issues which you have to take care of. So my report is generated now. Let's have a quickly look at it. So you have the overview. Okay, so number of variables is 24, number of observation 196, missing is 51, duplicate rows 1. So it will give you each and every information that you're looking for. Reproduction, so how it has worked. Warnings, let's see what warning it has. Here has constant. So these are some of the insights which this library throws you, like name is highly correlated with 6 other fields, person is highly correlated with name, and these kinds of information which you are going to have. Procurement product SLA has got almost 2% missing values now. So this is what, so these are some of the information you are going to get. So number of missing, number of unsupported, and all these things. So in terms of variable type of information, these things you are going to get. How many distinct are there, how many unique are there, how many missing are there. Based on each of these variables you are going to get. It's just a report summary which you will be getting. Let's look at the correlation summary. Let's select product SLAs and contact number, product MRP. So I'm not getting anything. Okay, let's look at the cross correlation which you're going to get. The Pearsons, Spearmans, Kendalls, and Fells. You have got Kramer's. Kramer's is for the categorical variables, where you get the different, where you get the relationship between different categorical variables. That's what Kramer's V is used for. For Pearsons and Spearmans, these correlations are used mainly for numeric variables. If you see, it has got highly negative correlation. Product, procurement, SLA, and customer IDs. Now, so correlation is a relationship between two variables. It can be, the range is from -1 to +1. Minus means it is negatively correlated, like one increases, the other will decrease. And if the correlation is positive, like if one increases, the other will also increase. That's what correlation is all about. It's a relationship between two important variables. So Spearman's and Kendall is for numeric, and Kramer's is for the categorical. So you have how many missing, matrix, heat maps, dendrograms. So all these kinds of information you are going to get from these. And lastly, it will give you a sample of the data set, the first 9 to 10, first 10 rows and the last 10 rows of your data set. Is going to also share with you which duplicate data you are having in your data sets. So that's about Pandas profiling. So that is so much interesting. So based on these, we can see your maximum EDA or exploratory data analysis is done. Okay, so we have known what is cleaning and not cleaning, and why we clean, what is cleaned and not clean data, and why we do pre-processing. Okay, so let's have a quick round. Let's talk about all the things we do for the pre-processing. When as I told you, data can come in from any kind of data sources, be it MySQL, be it Redshift, be it SQL, okay, Oracle, IBM DBs, Druid, Cassandra, MongoDB. It can come from any of these data sources. Okay, the first job is to consolidate this data, where you create one flat file or the least number of flat files. Okay, the next you are going to do is change the data types. So like for example, as I told you as I showed you, you are changing the data formats, like where the say date of birth is coming as a numeric, it should be changed into a string or a date type format, so that you do not do some manual calculations with it. So that is something which you have to do. Next is the missing value treatment. Okay, suppose if you have any kind of values which are missing or not present, so you have to take care of that. There are a couple of things which you can do with the missing values. One is you can remove the records where you have got missing values, or you just replace the missing values with some value of yours. It can be a numeric, it can be a string. In both cases you might come across missing values, and this is one of the critical problems which as a data scientist or which as an organization faces in terms of data. Outlier treatment. Outliers are, you can say, which just stands out or which are just out of the box. I'm going to cover this in the later part of this session. What is an outlier? Okay, variable transformation. Variable transformation is all about when we are changing the format, or we are, like for example, it's present in some currencies, we are changing the format, or you are combining these data with other variables. You might come across such things where we do such transformations, or where we change the data formats. Normalization and standardization means when we are changing when you have got data of different formats of different types, so just to maintain the, so that we every data is in the same format, we do normalization or standardization. Dimension reduction is when we are looking for, like for example, you have got thousands variables and it becomes very difficult to manage the thousand variables. What we do, we group those variables which are similar in nature. That's all about dimension reduction. Okay, for categorical variables, we do a categorization which is known as bins. Okay, what do we do in that? Like for example, we have got zip codes of the pin codes of different locations. So what we do, based on the location or based on the distance and based on the location, we group certain pin codes into one location, and based on that we do the analysis. And finally we come up across with EDA. As I told you earlier, it is about exploratory data analysis, where we find out insights into the data, we find out the trends in the data, we find out what these data is talking about, we find out which are our independent and dependent variables, and what is the relationship between the dependent and independent variables. Because when we are modeling, like for example, I just showed you earlier, we are finding an equation y equals to mx plus c, be it a linear or non-linear equation. Our focus should be, though we should target those variables which are have high relationship between different variables. Suppose we are I am wanting to find out the dependent variable, but I should take only those independent variables which are highly correlated with the dependent variables. Talk about a little bit about what is EDA and what all the things we do in the EDA. We take the cleaned data. Okay, now once your data is clean, like your data is out of outliers, your data is out of missing values, your data is in a proper format, your data in a proper scale. So once you have that data, we find out some descriptive statistics. Okay, you can say descriptive statistics. In descriptive statistics, we find out the mean, we find out the median, we find out the mode. Okay, we find out this kurtosis, we find out the skewness. Kurtosis and skewness tells you about the distribution of the data, how skewed is the data. Skewness is flattedness or peakedness. Kurtosis tells you like how your data is distributed. It's just about how your data is being distributed, whether your data is normally distributed or not normally distributed. Also we find out VIF. Okay, what is VIF? Variable information factor. What is this VIF? VIF tells you the relationship between the independent variables. It is also known as multicollinearity. Okay, what is this multicollinearity? This is a huge problem for building a model. Here in multicollinearity says that your independent variables are highly correlated with each other. So when we are building a model, you should make sure like your independent variables are not related with each other. Dependent and independent variable might be related with, should have the relationship very high, but between independent and independent between the independent variable there should be no relationship, or should be as less possible relationship. Between dependent and independent, relation should be stronger. Between the independent variable, it should be as less as possible. So VIF takes care of that, where your relationship between independent variable is as less as possible, and we take only those independent variable which are less correlated with each other. Okay, the next is we do feature selection. Feature selection is all about we are selecting which variables we are going to include in our model. For that we have got different informations like IV and RFE. Okay, and the last step is about class imbalance, or that is optional. Like for example, when classification problem, this is you're going to face these kind of issues. Or like when we are dealing with fraud detection, where like for example you have got two classes, say yes or no, and you see like yes is almost 10% compared to no, where it is 90% of the data. So that is what class imbalance is all about, where we have to take care of the data. You have to take different weights and go about building the model. I was talking about outliers. So what are outliers? Outliers are those values which falls outside the graph, or which, if you see, look at the picture, these are just falling outside. So there you have a scatter plot, and these values are just falling outside the graph. So that is all about outliers. Okay, and missing values is if any information is missing, we call it a missing values. Okay, let me just show you over. Come on, get back to your data. Let me just open up this file for you, and I'll just show you what is an outlier and what is a missing value. So if you see, let's look at this column. Okay, delivery C days. You can see the maximum information we have are in numbers, whereas there is also a value which is coming as /n. /n can also be termed as an outlier, because this is an entity which shouldn't be present but is present. So similarly in customer IDs, you see #n is coming. This is again this is not an outlier nor a missing values, but this is something which shouldn't be present. So these are junk values which will come in. Similarly like /n, these are junk values. So you have to remove these things. Now look at the GMV. Can you see these two values which are huge? So these are termed as outliers, where these are just falling outside the box, or these are just beyond. That is all about an outlier. Let me show you if I have got any missing values or not. We have a missing values here. You see data is not present, so that is all about missing values. Let me explain you about an outlier a little bit more. Okay, when you have your graph, okay, there are two things. When you have got data, you have got two things that you consider. One is a lower control limit, and the other is an upper control limit. By lower control limit is your 25th percentile, and upper control limit is the 75th percentile, and in between what comes is your 50th percentile. You know what is the percentile upon 100? That is your median. Okay, so whenever you have got any data set, we calculate the LCL and the UCL. LCL is the 25th and the upper control is the 75th. So most of your data will fall within this range, the upper control and lower control limits. And if any data falls outside here or outside there, that is termed as an outlier. Okay, so and the best representation of an outlier is a box plot. So what is a box plot? Box plot, as the name suggests, is a graph which looks like a box and which has got whiskers. Okay, so you have got lower control and you have got upper control, and there will be a median. Okay, so any data will which are falling, any data which is falling in this range is your data which is devoid of any outliers, but any data falling here or falling here are termed as outliers. Okay, that's the like box plot is one of the representation which helps you in very easily identifying an outlier. So as I was talking about normalization and standardization, suppose your data variables are of different scales. So normalization is done so that it's of the same scale. Normalization and standardization, where your mean is 0 and standard deviation is 1. So what we do, we take the data and deduct it from the minimum, and we divide it by the maximum and minimum. So that's all about. So just to have of it on the same scale, we do normalization, or we can do standardization. Okay, the next thing that we are going to do with the data types is of the category. This is for dummy variable creation. Dummy variable creation we mainly do for the categorical variable. So let's see how this dummy variables is done. So we can look at this one. Let's take look at this variable. So what we do, we have say variables of COD and prepaid, and when we have got two classes here. So what we do in this dummy variable is, I'll just show you here, we insert two columns and we name it as say COD, and we name it as prepaid. So where there is prepaid, I type 1, and where there is COD, I type here, and the rest will be 0. So it is again binary coding which is done. Like whenever there is COD, it will be 1, and the other will be 0. So here you have prepaid. In this case, in this column it will be 1, and the other column will stay as 0. So this is what dummy variables is all about, because it becomes very difficult when you are building equation, or you're building a model, or you're doing the modeling. So that's why we change the data format into dummy variables. Okay, and for the categorical variables. And also what we do, we remove the main categorical variable, because this information is already information in these two columns. And also when we are dealing with like 5 or 6 or more than 10 dummy variables, so we take the number of columns as number of levels minus 1. Like here we have got 2 levels, but we will be just considering 1, because you see, if it is 0, that means the other part is present. If it is 1, it obviously means that this is present, that means the other is not present. So that's why the number of columns we will be using is just 1, that is number of levels minus 1. So how do we do that using Python? We do it using the pre-processing library of sklearn. So we do not do it manually. Yes, we used to do before when we were not using Python, but as of now this is how we go ahead and build the dummy variables. Let's talk about some of the algorithms which we have in machine learning. So these are most of the common algorithms which we use. We have got linear regression, we have got logistic regression, we have got decision trees, we have got random forest, we have naive Bayes, and we are going to talk about neural network. When we talk about linear regression is all about when we talk about a straight line. When we get equation like a linear relationship is there, we get a linear regression, and this is one of the most common techniques when we are predicting any value. For logistic regression, it's not it's a non-linear relationship that we are talking about, and the graph won't be would be a straight line, but it will be a curved graph when we are talking about. And here in logistic regression we talk about classification problems. Okay, and decision tree. What is our decision tree? You have heard about you have seen the hierarchical graph in your organization. Our decision tree is also like that. It is a tree based approach which we get. Like we want to predict what's the uh, suppose we are working on a classification problem and we want to find out whether this team is going to win or not. It starts with one of the nodes which is called a root node. There it will see like what is this, like for example which country we are playing. Say it is a home country or foreign. It says it is we so it how the tree splits based on the entropy scores or different scores or an IG values based information gain. These are all some of the terms which we are going to talk in details later in another course. But here it's, you can know it's based on different scores. We find whether this we define which is our root node and which node we are going to split. Okay, so whether it's going to be in foreign or in home. If it is home, so we say which what they are during which time the match is being played. Is it in a day night match or is it in the day? If it is day night match, okay, so who is batting first? What would, okay, team 1 or team 2? So likewise you have, it's a tree based approach which we get, and based on that our decisions comes up. A random forest you can say is a derived version of our decision tree, where instead of one trees we create couple of trees, and based on that, based on different votes, we find out the most efficient one which is gives our correct results. Okay, naive based, this algorithm is mostly used when we are dealing with multi-class classification or when we are working on like natural language processing problems. Okay, naive Bayes works on Bayes theorem. And lastly, the neural network. Neural network works on neural net or just like a human brain. So how it works is like from one input it takes the from one input it creates an output, and that the second output will become an input for that. It's a layered approach where neural network is all about. So these things we are going to cover not here but in a separate course. Let's recap of what are the things we have covered in this. We have learned about machine learning and how to build the models, why it is required to do pre-process, how we are removing the outliers and the missing values, how we are standardizing and normalizing the data, and we have a quick information about these algorithms. Thank you for watching this video. Don't forget to like and subscribe to my channel. Thank you for watching. Bye bye.